Okay, here we're just going to give you a quick outline of what a design model is and what it consists of. In our case it's going to be a MATLAB Simulink model. This particular one is an example from University of Drexel. The credits there they go to the team 37, who produced the model and distributed it on GitHub, which is good. And it's this team here: D. Hartman, K. Landis, M. Merer and S. Moreno, J. Kim, and also J. Kim. Thanks guys, I'll probably use a lot of your concepts here. So, moving on. We, on this model, we've set it up ready to play. Press the play button and it simulates very quickly, and when we open the GUI for the flight animation, we can see that there is a UAV here suspended in 3D space at the moment, and if we look where that is, it's in the middle of the 3D space. And what's actually happened by the model is it's plotted some data which maps the trajectory of that 3D entity in 3D space. We press the start button to generate the path from the data which was already generated when we ran the simulation, and we can see that the path went through a trajectory here. Also, whilst the animation was flicking through the data, we could see that the UAV attitude followed the data as well. So we run it again. You can see the UAV actually changing its inclination at the same time as the data being plotted. So it's actually plotting what happens after takeoff of the UAV. And we can look at that data at any angle. We can look at the path from behind, from the front, from the top, and so on. Now, this particular model is not capable of generating code, as it has states in it which are not discrete. In other words, it's got states which require simulation at periods in between discrete intervals that we are only capable of simulating when the model is actually put into hardware. The hardware is not capable of simulating models with variable steps. So there's techniques we can use to convert this model to put into the hardware, but it's involved, and it's much better if you start a model from scratch with the intention that you're going to generate code, which is what I'm going to do. But I'll probably use a lot of concepts from this model. The next model I'm going to show you is for a wind generator, and the reason I'm showing you this one is because this also uses some tools which I think are much more powerful than the tools used by the university model. The universities, I've worked with the universities in the past on the Australia programme especially, and we know from experience that the universities prefer the students to work from first principles using very basic tools rather than advanced tools, because that saves a lot of work and effort, and the students don't learn the subject thoroughly if they use powerful tools that enable them to bypass the effort. In my case, I want to bypass the effort, so I'm going to use the powerful tools. So, to give you a demo of that type of model containing some stuff from there. Wind turbine, here we go. And I'll just bring that onto the screen so you can see it. This one is done with a tool set called Simscape, and it uses Simscape gives you mechanical, electrical, hydraulic and other physical system modelling primitives, so you can actually build the system the way it works in practice by connecting together elements which are already built in Simscape. So you've got things like blade, cylinder, rod, rotors, all those things, and they've made up, MATLAB have made up this demonstration model of a wind turbine, which is a fairly complex system. It's got the electrical generation in it, it's also got the aerodynamics of the blade loading, and quite a lot of detail. The simulation takes a bit longer on this one. Let me just run that. I'll move the MATLAB window back over so you can see what's going on. The model is still simulating there, it's just about to finish. Okay, and it's just plotted data in the same way that the other one did. Now this time we've got 3D shaded graphics, and again it's running through a movie of the data that was generated during the simulation. But this time it's a much more detailed 3D movie, and this type of model is more suited to the application of the REMMI UAV, because we can model the motors, the electrical systems and everything far more thoroughly than we could if we were doing it from first principles, with more confidence, because the blocks that are supplied in these type of toolkits have already been tested. So you're using blocks which have already been validated. The third model I'm going to show you is how these things actually get put into hardware. Now, all of these models potentially can be put into hardware. They just need to be either designed in the first place for code generation, which means you're restricted to a certain set of elements that, you know, some elements you can't use, or if you have an existing model like this, you can go back through and replace all the elements, you know, which may not be compatible with code generation. The model that I'm going to show you how to get into how it goes to it's just a quick sketch here. The piece of hardware, or demo hardware, is a Raspberry Pi. The Raspberry Pi comes in many forms, boxes. This one is like for children, the typical sort of thing that you get in schools. This one's my daughter's. I bought this for her Christmas. She was really happy. She's actually the programmer. Okay, so you can see the card there, and in the back the electronics. It's just quite a small thing. The one that is actually I'm going to demo is this one here. It's probably a bit more of a adult case, grown-up case, should we say. There's a camera here attached to that, and we have also network cable and the USB for the camera, and there's a power cable, and we've got a memory card there, the SD card, which is effectively the operating system of the Raspberry Pi. Raspberry is basically a Linux system, and it turns out that MATLAB Simulink, they've developed a target hardware package which enables you to code generate to put models into these things. So how does it go in there? We use a toolkit when we design, so this design is from the bottom up for code generation. I'm going to use a couple of tools in here for especially for the Raspberry Pi. This is from the Raspberry Pi toolkit. We have an SDL video display, which I'll drop in there. We have, I've just lost the Raspberry Pi toolkit, hang on 2 seconds, we find that again. Okay, video capture, we want that one as well. Just put them there, connect them up. Once we've done that, we've got a model. I just saved that, I've called it a camera demo. we need to deploy that now to the Raspberry Pi to demo the model. What I'm inclined to do, it's already on inf and external, which means if we run it now, it's on external mode here. It will run in the Pi, and you can see on the bottom here, building, preparing the model to run on Raspberry Pi. That's a dialog just here. Downloading the model to the Raspberry Pi, and that is running a DOS window in the Windows system, which is telling us the status of the model in the Pi. And now we can see a small window here with a TV screen in it. I'll just try and get that somewhere sensible. I think it's disappeared. Right, try that again. Okay, try and run again. So we lost the demo window there. I lost the demo window. Is it going to open again when we run it a second time? Okay, that's the model running. Running the model on the Raspberry Pi. The demo window doesn't appear again. Camera demo. Bear with me while I just look and see if I can find that. Yeah, video display. Right. So you can drag it down here. Right. Okay, so the video display is there. You can see that it's actually this camera here, which is attached to the Raspberry Pi. So what we've just done is created a program which runs on the Raspberry Pi, displays the picture from an HD video camera, and streams that information back through the Ethernet cable through the network port into the computer via the network port at which the computer is connected to the network. And we, within a couple of minutes, created a program that runs and does that. So that's basically what code generation is about. That's how it works. And at work, you know, in my employment with Cobham, I've used this technique for many different applications, and you know, quite often very complex models. But what I've just shown you is the basic how it works. So that's about the size of it. The other thing I would mention about that, we've also got a 3D modeling environment for making the UAV, which is this one. This is called Blender, and that's freeware. And in here we can navigate around a 3D model, and that we can export to various places, to especially the virtual simulation environment. And in there you can see my avatar in there at the moment, and the 3D model is there on the table. So I've imported that from Blender into the 3D environment, the virtual world environment, and this is going to be the REMMI UAV. This is the first version of the REMMI UAV, which is in the simulated world, and that will be the body of the UAV, which will be used for training purposes in the simulated world. So the other thing about this Blender the reason I'm talking about it, whilst we're talking about the design model, is that this can be used to calculate the centre of gravity and the mass and things. That model we would expect to be a thin shell, hollow. The tops of these will be cut off, and there will be propellers on each one of those. And the whole thing will be made from carbon fibre, 3D printed in one piece. So it will be as light as possible and as strong as possible for a material like nylon. And the information from the Blender 3D model editing environment on mass and inertia and moments of inertia would be imported into MATLAB Simulink to give us the information that we need to put into the thrust calculations that are used in the software. So I think that's about the size of it. I'll let you go for now until the next time. Thanks very much for your time. Looking forward to doing business with you. Speak to you soon.